Welcome all. In this video, I would like to explain about the projection of solids. First of all, let us remember the two group of solids. Solids having top and base of same shape, like cylinder, prisms, etc. So first is a triangular prism, a square prism, pentagonal prism, hexagonal prism, etc. And group B is solids having base of same shape and just a point as top called apex, like triangular pyramid, square pyramid, pentagonal pyramid, hexagonal pyramid, etc. Another is a cube. And a tetrahedron, which is a solid having four triangular faces. Let us see the different types of solids. There is a square prism, a square pyramid, it is a cylinder, it is a cone. This is called the top, and four faces are there. Longer edge, corner of base, edge of base. This is called the apex of the pyramid, the slant edge, the base, edge of base or base edge, corner of base, triangular faces. Square pyramid has four triangular faces, and cylinder and cone. These are called generators, or imaginary lines which are generating the curved surface of cylinder and cone. The base, apex of the cone, and base of cone. These are the sections of solids, and the specialty is the top and base are not parallel. At the same time, these are sections of solids of which the base and top are parallel to each other. So these are three cases of a triangular or pyramid resting. The first one is resting, standing on HP on its base and its axis perpendicular to HP and parallel to VP. The same is tilted rightwards, or resting on HP on one point of base circle. It's a cone. One point of base circle. Axis inclined to HP and parallel to VP. This is lying on HP on one generator. Its axis inclined to HP and parallel to VP. Observing here, we are observing the front view in which the solid is resting on HP. Here in top view, the XY line represents the vertical plane it is resting on the vertical plane. So it is standing on vertical plane on its base, axis perpendicular to VP but parallel to HP. It is resting on VP such that one of its base circle and axis inclined to VP but parallel to HP. So another top view lying on VP on one generator as its axis inclined to VP but parallel to HP. These are the steps to be remembered. Assume solid standing on plane with which it is making inclination. For example, in the first figure, it is shown that, or it is said that this cone is inclined at an angle with HP. So, for the first figure is drawn in the front view and top view such that it is resting on HP perpendicular to HP, resting on HP. And we draw the front view and top view in such position. Then it is inclined to HP. So the second figure shows the front view when it is inclined to HP and its top view. And the third figure shows it is inclined to VP. Or this is the top view of this figure, inclined to VP and its front view. So this solid is inclined to HP and then inclined to VP. Similarly, a cylinder, it is inclined to HP, then inclined to VP. A cone, it is resting on VP or the axis perpendicular to VP. Then it is inclined to VP, then inclined to HP. This is a cylinder resting on VP, perpendicular, the axis perpendicular to VP but parallel to HP. Here it is drawn inclined to VP, its top view and front view. Then it is tilted, inclined to HP and its top view. So these are the three steps to be followed when a solid is inclined to both planes. Here we pass on to 12 problems. First four problems are general cases of solids inclined to HP and VP, and 5 and 6 cases of cube and tetrahedron. Problem 7, case of freely suspended solid with side view. Problem 8 is a case of cube with the side view. Problem 9, case of true length inclination with HP and VP. And problem 10 and 11, cases of composite solids or in auxiliary plane. And last problem, problem number 12, case of frustum in auxiliary plane. So a square pyramid 40 millimeter base side and axis 60 millimeter long has a triangular face on the ground, and the vertical plane containing the axis makes an angle 45 degree with the VP. Draw its projections. Take apex nearer to VP. This is the steps for solution. Let us see how it is drawn. So first of all, we draw the top view of the square pyramid. Then front view marking the axis 60 millimeter. So in top view we mark it as A, B, C, D and O. In front view, this point is, we can see the point B dash and C dash. A dash and D dash will be behind this and can be put in brackets. So this is point O, this is O dash in front view. So it is slanted, or the second figure is the reproduction of the front view of the pyramid in lying position. And draw its top view, combining the projections from this view and the top view of the first method. So the combination of lines gives a clear image of the salt. So here the line from A dash from here and A from here gives this point, and B from here and B from here combines to give this point, and C is getting by producing this point and from this point, and D is getting by producing from this point and this point. So the base. Similarly, O dash from this point is produced here, and combined with this point we get O dash O1 here. Now it is drawn, this view is drawn with apex nearer to VP and making an angle 45 degree with the VP. So this is the reproduction of this view. And from this we can draw the front view. From this and this figure we can draw the front view. In this figure, the apex is drawn away from VP. Here the apex is drawn nearer to VP, and here it's another view in which the apex is drawn away from VP. So this is the three steps: first, second and third. 3 steps are to be followed. A cone 40 millimeter diameter and 50 millimeter axis is resting on one generator on HP, which makes 30 degree inclination with VP. Draw its projections. It is self-explanatory. The top view is drawn first. The circle is divided, or the top view is divided into 8 or 12 equal parts, so that we can draw the generators. Here only 2 generators can be drawn, or if it is divided into 12 equal divisions, we get 2 generators here and 2 here. So that is the more simple method to divide it into 12 equal parts. We get a clear-cut image. This is the reproduction of the front view in laying down position. It is laying on one of its generator on HP. It is laying on O dash E dash. Now draw its top view. This is drawn with an angle 30 degree with the VP. It is drawn 30 degree with VP, and this view is reproduced here. From here or from this view and this view, we get the front view of it. Corresponding points are drawn and we get the front view. A cylinder 40 mm diameter and 50 mm axis is resting on one of a base circle on VP, while its axis makes 45 degree with VP and front view of the axis 35 degree with HP. Draw the projections. This is the solution. So its front view is drawn. It is given that the cylinder is resting on VP and its axis is made 45 degree angle with the VP. So it is the reproduction of this view. Draw its front view. Now it is drawn 35 degree inclined with the HP. This angle is 35 degree. The combination of these two, or projecting lines from here and lines from here, we can draw the top view of this. A square pyramid 30 mm base side and 50 mm long axis is resting on its apex on HP such that its one slant edge is vertical and a triangular face through it is perpendicular to VP. Draw its projections. Draw the XY line, square pyramid. It is said that it is resting on one of its apex. So its front view is drawn in such a way that on tilting we get it is resting on its apex. This is the front view and top view of the square pyramid resting on its apex. A cube of 50 mm long edges is so placed on HP on one corner that a body diagonal is parallel to HP and perpendicular to VP. Draw its projections. This is the body diagonal. This is drawn for the easiest reproduction of the image here. drawn. It is reproduced here. Here this even point comes here, so it is rotated. So this diagonal, OD diagonal, is perpendicular to VP, parallel to HP and perpendicular to VP. This method is used in isometric views or positioning all objects to draw the isometric views. A tetrahedron of 50 millimeter long edges is resting on one edge on HP, while one triangular face containing this edge is vertical and 45-degree inclined to VP. Draw the projections. Tetrahedron is drawn. Its front view. This is parallel to VP, so we get the true length in the front view. It is reproduced here, or it is made vertical to HP. Its top view is drawn, and then it is tilted. This edge is tilted 45 degree inclined to VP. Its front view is then drawn. Next we pass on to freely suspended solids. The position of center of gravity on axis from base for different solids are shown below. For a cylinder and prisms, it will be at the middle of this height, or h by 2. Here in this case it is h by 4. For cone and pyramids it is h by 4. That points has to be noted. A pentagonal pyramid 30 millimeter base sides and 60 millimeter long axis is freely suspended from one corner of base so that a plane containing its axis remains parallel to VP. Draw its three views. So it is a pentagonal pyramid. Its front view is drawn. These three lines are seen here. Center of gravity is at a distance of h by 4. So it is hanging on this point D dash. It is reproduced there. D dash, G dash is drawn. And it is reproduced. We can draw the top view by combining these two figures. view from this direction is drawn here. A cube of 50 millimeter long edges is so placed on HP on one corner that a body diagonal through this corner is perpendicular to HP and parallel to VP. Draw its three views. Body diagonal is drawn as 1 dash A dash. It is drawn perpendicular to HP and parallel to VP. Its view looking in this direction is also drawn. A right circular cone, 40 millimeter base diameter and 60 millimeter long axis is resting on HP on one point of base circle such that its axis makes 45-degree inclination with HP and 40-degree inclination with the VP. Draw its projections. So here the front view and top view of the cone is drawn. Now it is drawn at an angle 45 degree with HP. It is reproduced here. Its top view is drawn and it is inclined at an angle 40 degree. Axis top view length. It is inclined at an angle 40 degree with the VP. Its front view is also drawn. A triangular prism, 40 millimeter base side, 60 millimeter axis is lying on HP on one rectangular face with axis perpendicular to VP. One square pyramid is lying on its face centrally with axis parallel to VP. Its base side is 30 millimeter and axis is 60 millimeter long, resting on HP on one edge of the base. Draw front view and top view of both solids. Project another front view on an AVP 45 degree inclined to vertical plane. This is the combination of two solids. Auxiliary vertical plane, 45 degree inclined to vertical plane. Its views are projected. Front view, top view and side view projected to the auxiliary vertical plane, auxiliary front view. A hexagonal prism of base side 30 millimeter long and axis 40 millimeter long is standing on HP on its base with one base edge parallel to VP. A tetrahedron is placed centrally on the top of it. The base of tetrahedron is a triangle formed by joining alternate corners of top of prism. Draw projections of both solids. Project an auxiliary top view on auxiliary inclined plane 45-degree inclined to HP. This is the auxiliary inclined plane, inclined 45-degree to HP. It is projected to that. A frustum of regular hexagonal pyramid is standing on its larger base on HP with one base side perpendicular to VP. Draw its front view and top view. Project its auxiliary top view on an AIP parallel to one of the slant edges showing true length. Base side is 50 millimeter long, top side is 30 millimeter long, and 50 millimeter is height of the frustum. So thank you.